Hello, hello, hello. How's everybody doing? Afternoon session about to kick off, or resume, I guess I should say. So we have, I'm Patrick Mulhern. How you guys doing? Everyone doing well? You get your caffeine yet? I'm not gonna make you do the chicken dance, that's Joe's thing, but just making sure everyone's there. So we got David Reed coming up. He's gonna give us some information on continuous integration. David does need introduction because he is actually joining us for his first Philly Force. He's coming all the way across the country from Santa Fe. So David Reed, everyone, little hand for his first. So prior to joining Radian, he worked with the ACLU and the Santa Fe Institute. He's excited about using Salesforce for good. And so he actually works and contributes to the open source community as well. And he's a certified platform developer 2, not 1. And holds an MA in Greek philosophy. What was it? Ancient Greek. So like many of us, he came to the ecosystem in kind of a very different, unique way. So without further ado, here is David.
Thank you, Patrick. Hi, everyone. As Patrick said, I'm David Reed. I'm here today to talk about continuous integration on the Salesforce platform, using the Salesforce DX toolchain and the CircleCI continuous integration provider. You may note that the subtitle of my talk is Practices and Principles for All, and there's a reason for that. This talk has two sort of sides to it. On the one hand, I want us to go through continuous integration at a conceptual level, because I know there's probably a lot of folks in the audience here who haven't previously worked in a CI environment or haven't had the opportunity to set one up on the Salesforce platform in particular. So we're going to start with a conceptual kind of overview, an introduction of continuous integration, what it is, what it does, what value it can add to your development lifecycle, your release management. But I also want to look at the practice side of the equation. Those concepts, I think, are much more valuable if we have an opportunity to make them concrete, to pin them down, by looking at how continuous integration is actually practiced. So a major part of this talk will be working through the setup, the creation of a continuous integration environment and workflow on top of a Salesforce development project within Salesforce DX. And finally, we're going to bring those things back together, of course. A little bit about me. As Alex mentioned, I'm a certified platform developer 2 here at Radian. As a side note, I should say, this is not an official Radian talk, so please don't take anything that I'm saying as an endorsement by Radian. I also have a GitHub that you can see here. All the code I'm going to show you today is available on GitHub, so you can grab this and use it for yourself. You can create your own CI workflows based on what I'm going to show you. You can throw them away and start fresh, whatever you see fit. And additionally, I've worked in a few other development environments besides Salesforce in my career. I still write a lot of Python. It's an incredibly useful tool for adding to the platform and scripting the platform. But one of the things that I'm really interested in and passionate about on Salesforce is importing things that can be valuable to us from the tool chains, the development environments, the practices of other development environments in the world at large. So that's something we'll come back to throughout this presentation. I've already said the phrase continuous integration about 45 times, and some of you may be wondering what that means. So we're going to start today by looking at a conceptual overview of continuous integration and the role that it plays within the development lifecycle. We'll look at how the different systems that are involved in CI connect to one another, how they're exchanging information, authenticating to one another, and so forth. We'll also look at what the benefits are of adopting CI as part of your development process and practice. And once we have that kind of framework in place, we'll go over to the practices side of this talk and start to build a CI environment and a new Salesforce DX project. We'll do that getting very much into the weeds of the technical steps, because I want you to be able to go away from this talk saying, I saw how this happens. I understand that there are concrete steps that I can take on my machine that lead to the result of me having this complex environment set up and ready for me to use. Towards the end of the talk, we're going to put all these things together and look at an actual development workflow where we'd be writing some Apex code, making declarative changes in the user interface of Salesforce, putting those things together, and seeing how continuous integration can help us guide that development process and surface any issues that come up. And we'll look at some next steps, some additional tools that you can integrate within a CI environment that add even more value or insight to your development process. So let's get started with the principles half of this talk. What exactly is going on with continuous integration? At the root, continuous integration is a method whereby you can build and test your software. I'm not saying Salesforce here, by the way, but any software continuously and automatically with no human intervention required. That's the continuous part here. The idea of a continuous integration workflow is that any time you are writing code or on the Salesforce platform performing declarative customization of your Salesforce instance, you should be getting feedback from your system, from your development process, letting you know whether what you have done is being successful at this time. In this case, being successful means, do you have internal consistency? Is everything put together in such a way that it can be part of the same Salesforce org without conflicts? And are all of the tests that you have written currently passing? This process is something that happens automatically, as I mentioned. So it's dependent upon a version control repository, which you may already be using as part of your development process. Continuous integration is going to start when you check in your code, when you push it to your Git repository, where you manage all of your team's work. At that point, there's going to be this behind-the-scenes process that we will set up that takes all of that code and metadata, puts it into a server, checks that you have consistency, runs your tests, and gives you back some feedback about where you stand. I'm using a lot of developer-specific vocabulary here, but I want to make sure that we establish that CI is not just for developers. And this is something that's actually kind of unique about the Salesforce platform and how we're going to use CI on Salesforce, because we have this bifurcated but mutually beneficial approach where we write code, but we also do declarative customization. Just because you don't write code or you don't write Apex unit tests does not mean that you can't get value from using a continuous integration approach. And I'm going to show you how that would actually work later on in the presentation. If you're an administrator and you work in an organization alongside developers who are writing code and writing Apex unit tests, you also have value to gain from this because your work doesn't exist independent of developers' work and vice versa. Validation rules influence unit tests, for example. Process builder and flow and workflow rules can work alongside or can conflict with triggers that are written in Apex. So all these things are part of the org, and the continuous integration process, as the name implies, integration, has to do with the whole org, its internal consistency, and its behavior. CI also offers value for other members of the development team. If you're somebody who is responsible for release management, for example, CI is something that can give you insight into what your code base, and when I say code base here, again, I mean not just Apex code base, but also declarative code base, all the metadata and declarative customization that makes up your org, how that code base is working, whether the new features that you've implemented are themselves working, whether they're impacting any of your existing code, and whether the whole is hanging together as a cohesive unit. And of course, anyone who is acting in a leadership capacity overseeing development activities wants to get this kind of insight into the development process, and CI is going to be able to surface results for those individuals as well. The foundations of a CI workflow, as I mentioned earlier, start with a version control repository. We're going to be using Git in this presentation, but it doesn't have to be Git if you're a Mercurial user or even potentially Subversion or some other VCS. You can still make use of this workflow. And the other foundational tool that we have is Salesforce DX. I'm not going to go into the fine details of Salesforce DX here, but a couple of concepts that I want to bring up and make sure we're familiar with before we move forward on are the idea that within Salesforce DX development practices, the source of truth about everything that you've developed, not just the new features, but everything that's part of your org, is your version control repository. It is the textual source code of your Apex, your JavaScript, your custom objects, your workflows, your page layouts, and so on and so forth, which is stored in your version control repository. And also the concept of a scratch org. A Salesforce DX scratch org, if you haven't had a chance to work with those in your development process to date, you can think of it as a completely empty sandbox. Empty not just of data, but empty also of metadata. It's attached to your production Salesforce instance, but it doesn't influence your production Salesforce instance. It's totally empty, bone stock, vanilla Salesforce. And that's something that we're going to use in the course of implementing CI, because we're going to take all those customizations and place them in a scratch org to perform our tests. So let's get down to what a CI flow actually looks like. If you are a developer or an admin or a developer admin who is working on building a Salesforce product, you're always starting, of course, with writing code. And again, I should say writing code can mean Apex, it can mean JavaScript, it can mean XML, it can mean Process Builder and Flow. You're writing your code against a Salesforce DX scratch org. You're committing your code to your version control repository as you're working with Salesforce DX. If you're making declarative customizations, you're pulling those customizations back down into your local store and committing them to that source of truth, your version control repository. And then finally, at some punctuated sequence within your development process, you're pushing all of that material to your team's central version control repository where it becomes part of your project history. That's the point where CI is going to kick in and take over here. Once you perform that push, once you get all of your code up into your version control server, the continuous integration provider, which here is going to be CircleCI, but in your organization could be Jenkins or could be Travis or some other solution, is going to take all of that metadata, code and declarative, that's stored in your version control repository, and it's going to create a new scratch org that contains only that material that you've committed to your version control system. It's a snapshot, a perfect snapshot of the state of your development process at that time when you perform your version control push. It's important to remember that it's the whole org, by the way. It's not just, if you're working on a new feature, it's not just that feature. It's not just the unit tests for that feature. It's everything that you have created as part of this project, however you define the boundaries of that project. We're putting that into a scratch org. So we've got a brand new Salesforce instance that lives up in the cloud somewhere that has all of our work on it. And we're going to run our Apex unit tests against that scratch org, not against one of our long-lived sandboxes, not against a developer sandbox or an integration sandbox, worst of all, or against production. It's going to all take place in this scratch org. So we run our tests there. We'll pull those tests back down. They're going to sit on the server for a minute, and then we're going to delete the scratch org. It goes away. And there's no artifacts left over as part of that process. This is key to our being able to run tests constantly in the background. As all of you probably know, if you are in the process of building a solution and you're using sandboxes and moving metadata and code between sandboxes and your production instance using change sets or using Ant, you're running tests there, those environments get polluted. There are side effects to the things that you do. You create test data, you might tweak a piece of code in one environment but not in another. They get out of sync, and your tests start to fail in different, interesting, unusual, difficult to troubleshoot ways. What makes it possible for us to do this whole continuous integration thing, where there's no human intervention, where it's all running in the cloud, is the use of those disposable scratch orgs, where we never have to worry about artifacts and side effects, because we spin it up empty, we put all that code that we've created into it, run our tests, and then we get rid of it. And that scratch org is never used again. It's gone. Next time we do a push, we'll create a new one. So overall, what you get is two endpoints here. You do a git push, and then you get back a summary of your tests. In this case, we ran 27 tests, and none of those tests failed. That's good. This code is green. We could potentially move it into one of our long-lived sandboxes. We're doing well. This is leading me towards one of the major benefits of continuous integration here. We haven't seen a failure yet, but one thing that I want to offer you as an observation and try to demonstrate to you during the course of this talk is this, which comes from Zane Turner, who wrote a series of great articles on the Salesforce developer blog about Salesforce DX. And Turner says, if I've made an error in my updates, correcting and testing multiple versions of an app takes minutes, not hours or days. Now, I don't think I actually took a time reading the last time I had to troubleshoot a regression in one of our long-lived sandboxes or worst of all in production, but I'm pretty sure it was more than minutes. And I want to show you during the course of this presentation, I want you to hold on to this because I'd like to show you that the minute resolution is actually a possibility because of the benefits that CI is giving us, starting with, most of all, visibility. At every point along your development process, because of the continuous part of continuous integration, you are getting visibility and insight into what your code's doing. Meaning, is it working? At the most fundamental level, is your Apex compiling? Do you have any references to custom fields that don't exist? Do you have any typos or dangling references between your declarative metadata? Does it compile? Does it work? Do your unit tests pass? Have we accidentally introduced any regressions in work that we've done previously that cause our org to move backwards? These are things that get surfaced to us immediately. You can see here, we're actually looking at GitHub, and we'll go back to this later. But one of the things that we get out of CI is an indication right away in our version control server that the code that we have committed as part of our team's history is good. We get a green check mark there letting us know that everything's fine with the code that we just committed. Additionally, if we add some more tools to our CI process, which we will later on in the presentation, we can get a look not just at yes, no, are the tests passing or are the tests failing, but also what our code coverage looks like and whether our code is following best development practices throughout. Another of the major benefits that CI offers us is a reduction in the inherent risk that's part of any development process. Building new code is hard. And designing declarative functionality that integrates with code is maybe even harder. One of the worst feelings that I ever have is realizing that some new work that I have done has caused breakage elsewhere, or that I've gone down a road that won't work because there's something else in my organization that's prohibiting me from taking a particular approach. Well, what CI can do for us is a little bit twofold in the realm of risk reduction. On the one hand, we're never going to unknowingly merge code that's broken into our master branch or push it to production, because we'll know as soon as we commit that code to our version control system that it is in fact broken, and we can take action to repair that. We can also bring up areas of major risk within our code before we start doing those merges or progressions through a series of sandbox environments towards production. So we try to surface bugs early and get them fixed as early in the development process as possible. The risk, I think, tends to go up the further that code gets along a progression of sandboxes towards production, that you're going to have a deep, complex bug that needs to be fixed. So we want to move the bugs earlier in the continuum, make them shallower bugs, and get them fixed early. But I think a more positive aspect of this risk reduction benefit of continuous integration is that it actually gives us some freedom to iterate on our development process and even create branches without introducing chaos into our whole development landscape. You can see here we've got a snapshot of one project that has 4 branches in GitHub, 3 of which are good. They're green with check marks, meaning that all of our tests are passing, but one of them has failed. That's actually a branch where I was building some Jasmine unit tests with the Lightning testing service. It's an at-a-glance summary of where your project's at, whether you're using feature branches or sprint branches or project branches. However you organize that work as part of your development flow, you get instant visibility into all of those different facets with your CI solution. So that means you can be a little bit more free to go ahead and create new branches, experiment, try new things, and you'll always know whether it's working or not and whether that code's something you can afford to keep in your org and merge further up into your tree. Lastly, I want to highlight a virtuous feedback cycle on how we practice good development on Salesforce that is enabled and pushed forward by the use of continuous integration. And what I mean by this basically is that you get more value out of a CI process if you're writing pretty good code already, and if you're writing pretty decent unit tests. The information that CI is giving you is only as good as what you can get out of your code. So if your code's returning good information, like a unit test says good, and that means your code's really working, that gives more value to your CI. But your CI also gives more value to those unit tests, because the more often you run them, the more often they're going to be catching bugs and regressions that could be introduced into your code or into your org. So we start to get this cycle here, where you write better code, you get more value out of your tool chain, and then that value that you get from your tool chain enables you to make better decisions and write better code. It goes around, and ultimately your code gets better, and you catch more bugs. So I hope that conceptual overview is enough to whet your appetite a little bit if you are not already practicing continuous integration and make you think that this is something interesting that could provide some benefit to my org, even as an admin or a declarative Salesforce user. So I want to change over to the practices part of this talk and look at how you'd actually do this kind of thing. And the way we're going to approach that is by building a completely new project starting from scratch. We'll use Salesforce DX, we'll use Git, and we'll take it step by step, getting very much down into the weeds of how we would create a continuous integration workflow. And while there is a lot of complexity and technical depth here, what I would like to show you, if I can ask you to not sweat quite all of the details, is that this is a very approachable problem fundamentally. If you have your laptop out, you actually could follow along with this, and I would be willing to bet that you would have a working CI infrastructure by the end of this talk. So let's go through this. And again, don't sweat the fine details of every command, but I want to show you how these systems are being connected together and how we're getting all of this working. And the first part of this is kind of a core setup for any project. It's very much boilerplate. You'd execute the same steps no matter what your project is. And the very first thing you're going to do is turn on your Salesforce DX Dev Hub functionality in your production Salesforce instance. Now, anytime you say production and change, that's kind of a scary prospect. But if you're not already using Salesforce DX, just rest assured there's really no side effects from turning on your Dev Hub. It's not going to damage your data, and it's not going to result in any alterations to your production org's metadata or code. So you go ahead and turn that on, and it'll allow you to create and use scratch orgs. The next thing we're going to do is set up our system architecture and enable authentication between our continuous integration provider and Salesforce. And this is a big, complex topic, but you may be wondering how exactly this cloud server, this magic cloud server that's going to pull all of your code and run tests and do a bunch of things about it, how's it going to talk to your Salesforce org behind the scenes with no human intervention? Well, the way we're going to get that set up is using an OAuth flow called JWT that doesn't require any human intervention. And it's a kind of two-factor authentication. You can think of it that way, which is often described as being something you have and something that you know. In this case, the things that we have are going to be a server certificate that lives on your production Salesforce instance as part of a connected app we're going to build. And the other thing that we have is an encrypted key file that lives in your Git project. The thing that we know is going to be the passphrase under which we've encrypted that key file. The reason we do this is because we're spreading out the information that we need to authenticate to production Salesforce, which no one wants to potentially expose to unwanted scrutiny, among the different systems that are involved here. Those systems are your Git repository. You can't put any confidential secrets there because that's exposed to your whole team, and it's part of a permanent project history. And your CI provider and your production Salesforce org. So what we're going to do, what we're going to do is make sure that there's nothing in your Git repository, in your project history, that contains confidential material, that contains an authentication secret, unless it is itself encrypted. And then we'll get this authentication set up so that you can connect into Salesforce and create those scratch orgs. First thing we'll do, I've got a terminal here on the left. We'll pretend it's a terminal. It's actually a picture. And we'll step through the creation of the project. First things first, we'll build our Salesforce DX project skeleton. We'll create a new Git repository. And we'll go ahead and commit all of the material that Salesforce DX generates for us. It's that project skeleton to that repository. If you're using GitHub, you can go ahead and add your GitHub remote here. If you're using some other VCS solution provider, you can connect up your repository appropriately. And then we're going to run this mess of commands with OpenSSL. Now, I'm not even going to pretend that I can actually explain to you the mechanics of what OpenSSL is doing here, because it's not important. This is the same for every project. This is a script you can just download and run. But what we're doing here at a conceptual level is we're building that authentication connection where we can get to Salesforce, we can get to our production Salesforce safely with no human intervention. The outcome of this process, after we encrypt that key file and commit the encrypted version only, not the plain text version, to our Git repository, the outcome is we've got a Git repository, it contains a Salesforce DX project, and it also contains an encrypted key file. Lastly, we've got a server certificate file, server.crt, that we're going to hang on to, because the next thing we're going to do is tell Salesforce, the other end of this connection, how we're going to be authenticating. So these are the things circled in red that we've got as a result of this process here. The next thing we'll be creating is in our production Salesforce, we're going to build a connected app. And that's what our continuous integration provider here, CircleCI, is going to use to connect to and authenticate to our production Salesforce org. Remember, there's not going to be any changes made to production. The purpose of this authentication is to allow us to use Salesforce DX scratch orgs, which are created by production. We need to authenticate for that purpose, but we're not going to be making any changes to data. We're not going to be doing any deploys, least of all, to production under this rubric. So we'll go and build a connected app here. We're going to put in a few OAuth scopes that will allow that CI provider to get in and make the changes that it needs. And most of all, we're going to upload the server certificate that we just created. That's the Salesforce side of the pieces that we have that are involved in this JWT two-factor authentication type solution. The one piece of information that you're going to pull out of here, which I've hidden from this slide because it's a secret and we don't disclose that publicly, is the consumer key for this connected app. You're going to take that and write it down somewhere secure like a password manager, because we're going to feed it to the continuous integration provider once we get to that step. To make sure that there's no click-throughs required, you know that OAuth window that'll come up anytime you authorize a connection to Salesforce? We don't want that because this is all behind the scenes. To make sure that's the case, we're going to pre-authorize the user under which CircleCI is going to be connecting into this connected app. So this is a very admin sort of flavored part of the setup. I had to learn a bunch of new things to get through this setup myself. So I'm mostly a developer. But that's what we're going to do here. I've got system administrator selected as my pre-authorized user profile. You don't necessarily have to do that. It's going to be dependent on what profile and or permission set you're using to select your CI user. But you'll get that set up. And again, that just makes sure that there's not going to be any prompts required. This is going to be run in a fully automated fashion. It's okay if you didn't get quite all of that. I'm not sure I could read it all back to you right now if I had to without the benefit of my slides. What I want to emphasize is that these are concrete steps. They're concrete steps that you could execute on your laptop right now with no additional software beyond what comes with most of the MacBooks that I see sitting around the room. And they're steps that you can get from any reference material that you might want. They're available on my GitHub, of course. They're also available through a number of tutorials from Salesforce. So these are things you can walk through on your own, concrete steps that you can use to start setting up a CI workflow. And what's critical here is the understanding that we take away of how these systems are connecting to one another. We've got multiple systems in the cloud. We've got our VCS that's talking to our continuous integration provider that's talking to Salesforce. And what we've done here is basically just made that possible without any human intervention. So the next piece we need to build, once we can get those foundations out of the way, get a scratch org ready, is we're going to build the actual test flow that will be used by our continuous integration provider to grab all that code and metadata, run all of our tests, and then report back to us on what happened. And I want to diagram out the architecture here a little bit, because I think it's more useful than me gesturing at systems in the cloud here and over here. So the pieces that are going to be involved here are our CircleCI server, that's our continuous integration provider. We've got a Git repository that lives on a server. We're going to have a scratch org that lives on Salesforce's cloud, and we've got our dev hub. So here's sort of what the sequence looks like as we're performing our development. The Git repository is going to send a message to the CircleCI server letting it know that a commit's happened. Someone's done some work on this project. And then the CircleCI server is going to take that and say, I want to execute my config.yml. And I'm going to explain what config.yml is in just a minute. But to be brief, it's a definition of exactly what needs to happen to build and test this piece of software that we're working on. CircleCI is going to take that and put it into a brand new empty Docker container. This is a virtualized environment that lives on the CircleCI server. It's running Ubuntu Linux. And it's got plenty of tools installed on it already. We're going to add a few more. And that's the environment within which all the commands are going to run that are required to make our tests actually go through. The Docker container is going to request a scratch org from Salesforce production. That's what we just facilitated with this lengthy authentication setup. We'll go to that scratch org, give it all the metadata, all the code and declarative work that we've done, and ask it to run the tests in that scratch org. Scratch org is going to send those results right back to the CircleCI server where they'll be stored for us, where we'll be able to get them and review them. And then lastly, the scratch org will be disposed. So that part of this diagram is gone. It's ephemeral. As I mentioned, the config.yml file is kind of the orchestrator, if you will, of the continuous integration flow. It tells the CircleCI server and that Docker container that we're creating what to do. How do you? It's a fully generic solution provider. It tests anything from Python to Java to C# to Salesforce. So we have to tell it exactly what is going to be required of it in order to get these tests done. And this is somewhere where I want to emphasize, and we'll come back to this, that we're going to be using and learning some tools that run a little bit outside the traditional Salesforce development pipeline, Salesforce toolchain. Here we're going to be writing some bash shell scripts. We're going to be using the YAML markup language. YAML ain't markup language, but it really is. We'll use CircleCI as our continuous integration provider, or in your org, maybe that's Jenkins, maybe it's Travis, and we'll be working in a Docker environment. I'd also want to emphasize again that templates for everything we're going to do here are available on my GitHub. So if you want to take this and run with it and do something different with it, you can grab these files, work with them, and move beyond them. A config.yml file is fundamentally a series of steps. And each step is a shell script. It's just a command that we're telling the Docker environment on that CircleCI server to run as part of the process of executing our tests and getting us back this insight, this information about what our code and our metadata is doing. So the first things we're going to do when we get into that virtualized environment is we're going to install Salesforce DX, because that's what we need to do everything. We'll use npm, the node package manager, to install SFDX on this container. And then we're going to decrypt the server key. If you remember, we committed to our Git repository an encrypted copy of the key that we're going to use to authenticate to Salesforce. You'll note here that we're using an environment variable, if you have good eyes, $key. That's an environment variable that we configure as part of our CircleCI setup at the end of this process. That's the thing we know, the other half of this two-factor authentication type setup. And we'll use that key to decrypt our server password, our server key file, and then authenticate into Salesforce. Throughout this, I'm highlighting in yellow, by the way, the verbs that we use with Salesforce DX to issue commands, because this is pretty information dense, and I want to show you what the skeleton is of this solution. The first thing that we do here is get an authentication grant. That's your force auth JWT grant command. That's using that authentication structure that we just set up at great length and great complexity to make a connection to your production Salesforce org, to authenticate securely, and then allow us to create scratch orgs. That's exactly what we do next. We'll use the force org create for, we're getting a brand new empty scratch org environment within which we're going to run all these tests. This is the meat of it. We're going to be pushing our source to the scratch org, and then we're going to run the test. That's just 2 commands in Salesforce DX. It makes it really easy for us, actually. A lot of this process is really in those boilerplate setup steps that we talked about earlier. Once we get down to it, the actual steps that we need to take to do the meat of CI, to push that source code up, to run our tests and get the results back, it's only 2 commands, force source push and force apex test run. Once that second command completes, we'll have our test results back and we're ready to go. Now, either of these commands can fail, by the way, but they fail in different ways to let you know what's going on in your source code. If we have an internal inconsistency of some kind, like we've made a syntax error in our apex, or perhaps a process builder XML definition has been edited to include a reference to a custom field that no longer exists. That's where we'd get that notification. We'd get something back from Salesforce DX saying, hey, we can't push this source because it's internally inconsistent, or there's a syntax error, or something else doesn't make sense. But provided that's not the case, we'll get that perfect snapshot that we talked about earlier of exactly what our project looks like at this point in time. The whole project, everything we've built heretofore, our whole team, is going up into that scratch org. We're going to run our unit tests, all of them. Again, not just the unit tests that we've written on the latest feature here, but all of them across the whole organization. That's how we get our integration, our continuous integration, and find any of those regressions that might be lurking. Whatever happens, whether these commands succeed or fail, whether we've got good tests or bad tests, we're going to clean up by deleting the scratch org. It goes away. Doesn't matter what happened. This is, again, as we talked about earlier, this is one of the reasons why there's no artifacts to this testing process. None of your sandboxes are impacted. If you have an integration sandbox, that's fine. Nothing happens to it. Nothing gets pushed to production. There's no deploys. There's no data changes whatsoever. It's just in these ephemeral environments in the cloud that are gone as soon as we're finished using them. The Docker environment, by the way, is also disposed. So that environment, that virtual container where we're running all of these commands out in the cloud somewhere on CircleCI, it also disappears at the end of this process. We never have to worry about it again. The only thing that comes out of this whole workflow is those precious test results that tell us what's going on, and they're going to be pushed back to us so we can take a look. The last couple of things that we have to do before we can start building, we're actually almost done with this process here of setting up and establishing CI, is we'll add this repository to CircleCI. We'll add a new project from our GitHub, and we'll configure the last piece of the authentication solution that we've built. We store these values in environment variables in CircleCI so that they are available to us in the shell scripts that we're writing to define the process. But they're secured from anything else. So they're not part of our Git repository. They're not visible by other members of our team. We actually can't pull the values back out ourselves, even if we're the project admin. They're just stored there securely, so they can only be used to authenticate. And those values are the consumer key that we pulled out of the connected app that we built a few steps back, the passphrase that we use to encrypt our server key, the piece that pairs with the certificate to establish that JWT authentication, and the username under which we're going to authenticate into production Salesforce, which of course has to have the permissions necessary to create a scratch org. So that's it, we're done. We've set up a continuous integration workflow. If we were building a real project here, if you're following along on your laptop, you could commit some code right now, push it to the server, and you get back test results. That's all you need to do. So I want to turn now to both sides, to practices and principles, putting it all together. And what I'd like to do is go back to that assertion that I showed you earlier by Zane Turner in that series of articles about how to use Salesforce DX, that the lifespan of a bug or a regression, an issue with an update made to an application can be reduced from hours or days to minutes. So I'd like to demonstrate that for you. And I'd like to do that by showing you a real development workflow, or representative development workflow, perhaps I should say, in which we introduce a regression into an existing organization, an existing project. We have that regression surfaced to us by our CI solution. We identify and make a fix to repair that regression, push our changes back up to the server, and then receive validation back from our CI solution that, yes, we've actually corrected the issue that was introduced, and we're ready to move forward with this code, whatever that might mean, even as far as going out to production. I'd like to do that by showing you a brief video. This video is going to run for 1 minute and 50 seconds. It's not in real time. It has been sped up. But just so you know, as a point of comparison against your experiences of identifying, troubleshooting, and fixing regressions, that performing all of these steps that I'm going to show you took me 9.5 minutes from beginning to end. So here we are. We're wearing our developer hat here. We're in Visual Studio Code writing some unit tests, putting the finishing touches on a unit test here for some code that we've just been writing. We're going to commit that code to Git and push it up to the server. And in a moment, we're going to get some validation on how those unit tests went. Our tests have passed, says CircleCI. That's great. Putting on the admin hat for a moment, we're going to switch over into the scratch org and build a validation rule. Looks like some of our users have been creating test accounts in production, and we don't want to encourage that kind of behavior. So we're putting in place a validation rule to stop it. If you have very sharp eyes, you might already notice that my unit test is creating test accounts. That's what a unit test is supposed to do. But my admin friend here who's on my team probably doesn't know that. And this validation rule that I'm pulling down now and making part of the version history of my project, the permanent record of all the work that we've done, conflicts with my unit test. You can probably already see that. So when we perform this push, our continuous integration provider is going to go off again, and we'll get back results for the whole org. What's working, what's inconsistent, and what's consistent. As you can see, we've introduced an inconsistency, a regression. Specifically, we're getting back from this unit test a field validation exception because of the rule that was just created by another member of our team saying we can't create test records in production. Fortunately, that's a really easy fix. There's a very simple, shallow regression. We're just going to change our unit test to use the word demonstration instead of dummy. Again, this is just a representative workflow, although I can imagine doing this in a real organization. So we've made that fix. We'll push that fix, and then we get back validation again from our CI provider letting us know that everything looks good now. Our tests are back to green, and our org is internally consistent. So we were able to identify that regression, commit a fix, and get back validation that we're good inside of 10 minutes. I think that's probably a lot faster than anything I've ever been able to do without the benefit of CI following along behind my development process and the development process of all of my team members with whom I'm collaborating makes possible. So we saw one mode by which you can receive results. And it's a pretty simple one. I just got an email letting me know, yes, I'm good, no, I'm not good. When we actually go into CircleCI, you'll get a little bit more detail here. In this example, you can see that we ran 8 tests and none of them failed. We can drill down if we want to and see more information about things like timing. You know, we have one unit test that took a whole 25 seconds to complete. That's actually a unit test that inserts 5,000 content note records. That's why it's so slow. We also get that snapshot that I mentioned earlier, where we see all of the branches that are part of our project, feature branches, sprint branches, what have you, and what their current status is. We've got one branch that's having a problem right now, but master is green, so we're good there. And we have a couple of other feature branches that look like they could potentially be merged in. They're ready to move forward. All of our tests are passing. But this is not just a workflow where you have to go and inspect things. That would be a lot less useful than what I've promised I can show CI to be. In addition to going and looking at your results in CircleCI or your continuous integration provider of choice, they're going to be pushed back into GitHub for you as well, or whatever VCS you're using to manage your development process. So you're always going to get a sense within your commit history of where your tests are good, where they're bad, where you might have issues. Here we've got some green check marks and red X's by each commit, letting us know where we're at. And you can also see, if you drill down, that we're running not just 1, but actually 4, in this instance, tests on every single commit. That's running tests, the first check. It's running static analysis, and it's also running 2 different levels of code coverage analysis. We'll get into that in a little bit. In addition to inspection, where you can go look at your systems and get back validity information, one of the great values of CI is that it will come to you and let you know what's going on wherever you are currently managing your development process. So if that's email, you saw in the video a few minutes ago that I'm getting an email from my CI provider letting me know that my build succeeded, my tests passed, or that my tests failed. That's one way you can choose to do it. If your team uses Slack, you can also connect your CI provider up to Slack, and you can get messages in an appropriate channel letting you know what's going on. You can get web notifications. Pretty much wherever you're managing your work, that's where your CI results can be flowing in. That's the whole point of the exercise, really, is that you're not stepping away from your day-to-day development practice. You're still doing your day-to-day practice, and you're having that practice enriched by a regular flow of results and insight from these code-based solutions that are running against your work. So beyond the basic workflow, and that's what we've established here. We've got a basic CI workflow set up where we can push code, we can push declarative metadata, we get back results letting us know whether we have consistency or not, whether our tests are passing or not. We can build some more functionality into our CI workflow to give us information that goes beyond thumbs up or thumbs down. And what I want to give you as one of the last pieces in this presentation is kind of a tasting menu of 5 more things that you can do with CI to get more out of it beyond those basic insights of are my tests passing and where are they passing. This is another area where I want to emphasize that we're stepping outside the traditional Salesforce development tools like Eclipse, Ant, Visual Studio Code. We're adding some more technologies outside, some technologies that are very common in other development stacks and environments. So here are some things that we're going to use. These are all represented somewhere in the presentation or other. Git, Mercurial, different VCSs, different CI providers like CircleCI, Jenkins, Travis, bash scripting like we saw in the config.yml definition file, Docker environments, Python. If you're a user of Ruby or Perl or any other scripting languages, these are all things that can be included as well. But the overall concept that I want to emphasize is that once we are scripting with CI, we have the power to build in all of these additional tools, whole tool chains, workflows, analysis products, many of which are very common in other development environments, but that we haven't always been able to use effectively on Salesforce. Because we're just writing shell scripts fundamentally, or connecting to APIs over and above that, we can bring all those tools in and knit them together loosely in a way that's very tailored to the specific needs of our development process and our development environment. We have the freedom to grab ways in which these tools have been put together, tweak them, make additions to them in a way that's very free and fluid until we get to an overall workflow that targets our specific needs as part of this development process. And what I'm going to show you are just a few of those additional tools and pieces you can connect with shell scripting or via APIs. The first one is called codecov.io. This is a code coverage monitoring service. This is a product that I was using on a different project where I was writing Python and getting back code coverage results in Python. I wrote to them one day and said, hey, would you consider supporting Apex? They said, sure. And about 3 days later, I got this, which is great. You're probably used to, in Salesforce development, going into your developer console or into Eclipse, running your tests manually and getting back the code coverage results through that kind of window. One of the things that CI is trying to do is to automate that kind of process. So an additional piece we can bring in here is automating the code coverage side as well. Here we can see one specific file. We're successfully covering all of the lines in this file. We can also step back and look at an overall project, file by file or folder by folder, and see where the code coverage looks as of this commit. At every commit along the way, we're recording this data as part of our CI process and getting it pushed into this cloud solution. Another tool that we can use of a very different kind is going beyond testing on a single org to test on a number of different orgs that look very different. So if you're an ISV, this is something that you might already be doing or find very useful. If you're an organization that has multiple Salesforce instances, potentially Salesforce instances of different types, like you've got a professional edition and an unlimited or enterprise edition, this might be something that you can use and get a lot of value from. In Salesforce DX, we use scratch definition files, which are written in JSON, to define what our scratch org looks like, including things like, is it an enterprise edition, or is it a professional edition, or unlimited, or what have you. We can also install different packages in those scratch orgs as part of our initialization process. So I said files, and that's for a reason. You don't have to have just one definition file that specifies what your testing org looks like. Here, you can have 3 or 2. One for an enterprise edition org and one for a developer edition org. As part of your CI process, you can be consistently, every single time, running all of your tests on your code base against multiple orgs that look very different from one another and getting back information about things that might not be working on, for example, a professional edition org, but that work great on an unlimited edition org. Another piece we can bring in that actually applies a little bit earlier in the development process as well is static analysis. Static analysis is something that is used very heavily in other development tool chains, but that hasn't always been part of our Salesforce equipment. Fortunately, some folks have done really great work in bringing the multi-language static analyzer PMD to Apex. What static analysis will do is look at your code without running it. That's what static means in this context, and attempt to identify locations where you have dangerous code practices or shortfalls in your code style or other issues that can be identified before the code is even run. In fact, before it's even pushed up to a Salesforce server. You can run PMD in a couple of different places. You can integrate it into your IDE. Eclipse and Visual Studio Code are both supported. But you can also run it on your CI process as part of that continuous review. So for example, if you want to make sure that none of your developers on your team accidentally commit some code that performs SOCL in a loop or DML in a loop, that's something we can detect using static analysis and have surfaced to us during the CI process. I mentioned earlier that there's multiple checks running in GitHub. That's what that summary information is telling us. And the second one is actually a static analysis job that's running to make sure that those code style, development practice type areas are looking good in the code that we're building. If you are working in Lightning for your projects, you may want to go beyond Apex unit tests in evaluating the behavior of your code. One way you can do that is by using the new Lightning testing service to build unit tests in JavaScript for your Lightning components using either the Mocha or Jasmine unit test framework. You can run those unit tests within your CI flow alongside your Apex unit tests. You don't have to open a browser to manually run this Jasmine test driver that I'm showing you here. This is something that runs silently in the background, just like your Apex unit test, and you get back all of your test results in the same format, regardless of which language they're running against. Lastly, and continuing the theme of looking at other languages that connect with Salesforce, if you are building code that integrates to the Salesforce platform, whether or not that code is connecting to Apex that's running on Salesforce, you can also use Salesforce DX in your CI workflow to perform not a unit test, but an integration test against that code that you're building. In this example, I'm building a tiny Python tool that connects to the Salesforce API to do something. It doesn't actually matter in this instance what that something is. What I can do is set up my continuous integration process to run Python unit tests written in Python against this tool, but then also spin up a Salesforce DX scratch org, pull out the authentication information for that scratch org, and allow my tool to complete an integration test by connecting to that empty Salesforce environment into which perhaps I've pre-populated some data or some code that's intended to connect to this external piece of my app, run my integration tests, and then get back my total results across the whole application that I'm building, both on and off the Salesforce platform. So I hope, again, that tasting menu has helped to whet your appetite for some of the really exciting things that you can do with CI on the Salesforce platform. I want to leave you with some links and resources that you can use to productively steal all the things that you've seen here, including all the config.yml definitions to do things like basic testing, multi-org testing, lightning testing service, and testing off-platform code. Those are all on my GitHub, and you're welcome to take them, build upon them, use them however you please. There's also some great resources that come out of Salesforce itself. If you're not already using DX, there's a great 5-part series that I really recommend that you read. There's an excellent trailhead showing how to do continuous integration using Travis, another continuous integration provider. And there's also an example repo for Travis provided by Salesforce themselves. So whatever you ultimately choose to do as far as designing your CI workflow, whatever tools you want to bring in, there's a wealth of resources available that you can take, adapt, put together, and use for your own purposes. Thank you.
All right, so judging by the amount of people I just saw pick up their cell phone and take a picture of that last slide, I'm sure we're going to have some questions for David. Also, I do want to mention he is graciously going to give the slides out, so anyone who wants them can get them.
Yeah, absolutely. Actually, the versions of the code that you saw in this presentation on GitHub are a little bit newer, so please use those rather than copying from the slides.
Hi, myself, I'm a PD2 developer, and we have this CI pipeline set up in our org. We use GitHub for VCS. We use SonarQube for static code analysis.
I'm sorry, I'm having a hard time hearing you.
We use GitHub for VCS. We use SonarQube for static code analysis, and we use Selenium for regression. One thing we do not use as of now is Salesforce DX. So I want to know what are the upside of using DX versus Sandbox. And secondly, I want to understand how pragmatic this approach, this solution is if the org size is, say, medium or large. Like, let's say having 2,000 test classes or test cases.
Yes, both good and important questions. On the DX side, one of the great virtues of DX is that it allows us to build a CI infrastructure really quickly and in a way that looks a little bit more like the CI that developers on other platforms might be used to. If you're practicing CI on a sandbox environment, I'm not in your org, but you may have run into challenges where your environments don't look exactly the way that you're expecting them to look, and you get test class failures for that reason. You may have side effects from testing processes that have run in the past, and those are things that Salesforce DX gets rid of because you're always testing in a completely empty, fresh environment. I'm not going to try to make a case that if you have a working CI process using sandboxes, you should throw it all away and switch. I wouldn't make that case. if you're setting up a new CI process, I think it's well worth your while to go with the DX route if you're able to do so. And one of the big challenges that people have found in adopting Salesforce DX, as the other half of your question points to, is big orgs that have a lot of customization that's already existing have a more challenging adoption path on DX than orgs that are starting fresh with this development tool chain. I don't have a great prescription for what that would look like. What Salesforce themselves have been telling us since the impetus of Salesforce DX is that second generation packaging and breaking up those large, heavily customized orgs into independent metadata packages or loosely coupled metadata packages is ultimately the approach that we'll want to take to convert those large scale existing orgs into a DX or DXable, if I can invent that word, development process. I saw some really encouraging things from Andy's talk earlier about unlocked packages that I think are accruing towards ultimately building that solution.
Quick reminder, by the way, guys, don't forget to talk about everything on social media to get a chance to win some prizes. So just make sure you use the hashtags for the conference. And we have one more from Scott.
So there are 3 different forms of authentication for DX. There's the web login, there's the JWT version, and there's also this Salesforce DX URL. I found that the JWT login to be very cumbersome to actually pull off, especially with creating certifications and then doing it for every single sandbox. The method that we came up with was to actually take that Salesforce DX URL, encrypt that, push that to the repo, and then have the CI process decrypt the URL and authenticate that way. Have you tried out this approach? And if so, what's the disadvantages compared to the JWT version that you list here?
I can't say that I've tried that approach. That's an interesting way to take it on. The question that I would ask, and I genuinely don't know the answer to this, maybe somebody in the house does, is whether Salesforce DX guarantees a lifetime for that automatic login URL and the access token that's appended to it. I don't know whether that's guaranteed to have the same lifespan as the Scratch org or not.
You have time for one more? All right, David Reed, thank you.
Thank you.